more to say about it. Okay. All right, string compression. Oh, that is the next one, string compression. All right, so before I screw it up again, let's just copy this out, go to chapter 1, problem 6, string compression.clj. Yes, oops. Yes, do that. Okay. All right, and so let's just call it string compress. I guess we just call it compress. Screw it, call it exactly. String compression. It's going to take an S, clearly, and okay. All right, sorry, I'll read it. String compression. Implement a method to perform a basic string compression using the counts of repeated characters. For example, the string AAB CCCCCCCC AAA would become A2B 1C 5 A3. If the compressed string would not become smaller than the original string, your method should return the original string. You can assume the string has only uppercase and lowercase letters A through Z. Okay, all right, that's cool. You know, maybe I should be reading the hints at the end of each of these things, just to see if I missed something incredibly cool. But anyway, I think this one's pretty easy. Oh, actually, there's literally a function for this, I think. So let's just take this. All right, let's finish this out. Yeah. String compression. All right, so let's start with the example. They have expected is actually A2B1C5A3. The input string is AA B. Why do they do that? There's no point in putting the 1 after the B. I mean, you should just implicitly assume that there's no number there. It's 1. C, 2, 3, 4, 5, 1, 2, 3. All right, so that's at least 1. However, the empty string should compress to the empty string. The A should compress to the A. And the ABC should compress to the ABC. And this isn't a true-false thing either. Oh, I did it kind of backwards, I think. No, I did it. Expected first, actual second, yeah. So expected, all right, so I think that's, I mean, there's not a whole lot. I guess, can I think of any other useful test cases to run that aren't just like me repeating myself in some way? I guess it might as well, if you were blind to what you've done, you want to check compression at the beginning. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. And you probably want to check compression at the end, right? 1, 2, 3, 4. Okay. All right. So let's see if we can get that to pass. And so I think this is actually I think this is an easy one in that all we basically need to do is, oh, you know, this is not ironic, but I think I literally said it as like, oh, remember group. That's a useful one, you know. So it's not frequencies, right? Because we do care about the order, but no, it's not group by either, actually. Well, actually, it can be group by. We can do it that way. But I feel like there's got to be just a sequence processing way to handle this. Oh, partition, maybe. Partition. Oh, split at, I think is maybe what we're looking at. Index. She seek, blah, blah, blah. How about split at? I like split at. Where's split? There it is. Oh, or split with, I think is what I mean. No, I want to. Oh, partition by, I think is what I mean. Huh. Group by shows up in. Yeah, okay. But you, of course, you. Okay, so I think we just partition by the identity, I guess, maybe. Let's see. So basically saying whenever the value changes, then partition again. Let's see what we got here. And what? Bull. Oh, well, that's because I just executed the last one, didn't I? Okay. All right, that makes sense. And I've returned a function and not partition by the identity, I meant to say. And so, cool. Yeah, I see this is equal to the empty string, this is equal to A, this is A and then B and then C. This is a bunch of A's grouped together, then B and then C. So yeah, this is, I think this is it, basically, you know. So now we just need to map. That's a weird level of... No, it's returning a sequence of sequences. Okay. Yeah, so I think we just need to map, and we take... let's just do a real function. But let's do x and xs, right? And we'll just say... No, actually, let's just do x as xs. And we will just take... we will just take... I guess we return the vector. Oops, I'm still in the actual argument. Let's start. We return a vector that contains x and will contain the count of xs, right? And that's fine. Let's just see what that looks like. Okay, so the big one I want to see is A5, yeah. Where's theirs? A2, B1, C5, all right, A3, all right, yeah. And so then we can just be cheap and just cheap and inefficient, just flatten the whole thing. I guess we have to flatten it anyway. Let's see what happens. And okay, and then I think technically we can just stringify the whole thing. Let's see. Whoa, that is not what I expected to happen. Closure. How did I get a lazy sequence? How did I get a lazy sequence? I called string on something. That shouldn't return a lazy sequence. What? So up to this point, I was understanding what was going on. I have a sequence of things. Okay. Then when I call string on it, I get a lazy sequence out. No, it's a string of the word closure. What? It's not doing... I think I see what it's doing. It's actually saying, what is this? And it's saying, well, it's a closure lang lazy sequence. But what I wanted to do is take the content of the thing returned by this and run string on it and return a closure lang lazy sequence. Okay, I think that makes sense. Okay. Not a good result. Oh, you know, I guess I was wrong about a lot of my examples, actually. I was just... Wait, no, I'm not. Oh, we never did the... are you smaller than the original? I'll just be impressed. Yes. Oops. All right, so if count of S I don't think it can really be equal to, right? Because the compressed has to at least be greater than the S. But anyway, if it was, then return S. Otherwise, return compressed S. Nope. ABC5. Oh, I forgot that is... Well, actually, that is not what I expected. Oh, I just did it wrong. My example is wrong. It should actually be... I forgot. Wait, wrong. Backwards. Okay. I think that's it, yeah. If the count of S is less than or equal to the count of the compressed S, then just return true. Or return S. Otherwise, return the compressed S. Okay, I think that makes sense. Alright, cool. And that was pretty much all thanks to our partition by friend. I made that all really easy. Oops. I forgot my... problem 1.5 Okay, so this is just problem 1.6 of Kraken decoding interview. Whoops.